Good morning, everyone. Today, we will be solving word problems involving functions and applying them into real-life situations. Okay, let's start. First, let's read the problem. A rectangular swimming pool with dimensions 30 feet by 50 feet is surrounded by a sidewalk of uniform width, x feet. What is the width of the sidewalk when the sidewalk area is 704 square feet? So it says here a rectangular swimming pool. So we need to draw that. We need to draw the figure. So rectangular, imagine this as our swimming pool, rectangular swimming pool. And it says it's 30 feet by 50 feet, meaning its width is 30 feet, and obviously its base would be 50 feet, or its length would be 50 feet. So this is, wait, no, let me draw that. I'll put it here. 30 feet and 50 feet. And it's the same here. This is 50, this is 30. So, and it says is surrounded by a sidewalk of uniform width. So next we have to draw our sidewalk that is surrounded by the pool. So let's do that. Sidewalk is, let's say this is our sidewalk. Not very good at drawing, so say this is our sidewalk. Yeah, like a picture frame. So it says here that our sidewalk has uniform width, meaning this and this is the same since it's uniform. So how do we solve this problem? And it says here that 704 square feet would be the area of the sidewalk. So how do we solve this problem? Well, first, since we're given the length and the width of the swimming pool, we can figure out the area within the swimming pool, the rectangular swimming pool. So, and we know that area of the swimming pool is equal to base times height for a quadrilateral, or length times width for a quadrilateral. And a quadrilateral is any four-sided polygon that has 4 points. So, yeah. So that would be the area of the swimming pool. Let's just say it's AOSP, area of the swimming pool, equals length times width, to which it is 50 times 30. Your width is 30, your length is 50, so that would be 50 times 30, which is 1,500 feet. So the area of the swimming pool is 1,500 feet. Now, how do we get the area of the sidewalk? Well, to solve this problem, we know that from this point to this point, the length is 50 feet. And we know that the width from this point to this point is 30 feet. But in order to get the length of the sidewalk, we need to know what this is, right? So we can connect it. And we can connect it here. We need to know what this is. Since we're trying to get the length of the sidewalk, in order for us to get the area of the quadrilateral sidewalk. So we need to know what this is. But we don't know what it is. So let's label it as X. Okay? I'm not doing anything, okay? I'm not trying to do anything. I'm just labeling it as X. Same here. We don't know what this is, so I'll label it as X. Yeah, makes sense. Same here. To get the width of the sidewalk, we need to know what this is. We need to know what that is. This and this as well. We don't know what that is, right? We have no clue what that is. So we're gonna label it as X. X on all sides. So technically, the length of the sidewalk is just 50 feet. The length of the sidewalk, this one, the length of the sidewalk is just 50 feet plus the other two x's. right? We can say it as that, since this is x and this is x, since we don't know what that is. So we can say that's 2x, since we add these two together, that's 2x. So we can say that this is 2x. And then 30, we can say this is 2x as well, since we don't know what that is. We just label it as x since, well, we usually label things with letters since we don't know them. We labeled it with letters for us to get the answer. So 30 plus 2x. So that's the width of the sidewalk. Yes, okay. So we have the length and width now. So that's our, that's what we need to solve for the area of the sidewalk, right? Okay, so, but we need to keep in mind some things. The area of the swimming pool is 1,500 feet. If we multiply this and this, we'd be getting the area of the entire thing, right? Since it's the quadrilateral, multiply this together, we'd be getting the area of the entire thing. So it makes sense to multiply these two and subtract it by 1,500 feet. Since we're trying to remove this part, since we're not trying to get that, we're trying to get the area of the sidewalk. If we multiply these two together, we'd be getting the area of the entire thing. And we don't want that. We want to get rid of this. So that would be area of sidewalk, AOSW, equals this, length times width, 50 plus 2x multiplied by 30 plus 2x minus 1,500. But look at the problem. The entire area of the sidewalk is 704. So we have to have an equal sign here because it says the sidewalk area is 704 square feet when the sidewalk area is 704 square feet. So this would be our final solution. I mean our final equation. And now we just simplify. So the FOIL method, 50 times 30, 1,500, 50 times 2x. Yeah, we're just foiling, multiply this, this, and that. So 50 plus times 2x, that would be 100x. 2x times 30, that would be 60x. 2x times 2x, 4x squared. Minus 1,500 equals 704. I just stuck it there. So we can simplify this even further. We can get rid of the two 1,500 since 1,500 positive minus 1,500, or plus and minus, that would cancel out and that would be 0, right? 1,500 minus 1,500, that would be 0. So we don't have that. So let's just pay attention to this part. 100x plus 60x, that'll be 160x. So we can say 160x plus 4x squared equals 704. And we know that in order to get the value of x, we need to transpose this here and factor it out, right? So let's do that. That would be 4x squared plus 160x. When you transpose this, become negative, and be equals 0. Right. Okay. We're on track. The only thing I did here, I didn't do anything. I just interchanged them together. I didn't interchange the sign. I just interchanged their position. So it'd be 4x squared, positive remains here, and then transpose become negative. So it's like that. To make it easier for us to factorize, we need to find the GCF. The GCF would be 4. So 4x squared divided by 4, that would be x squared. And then 160x divided by 4, that would be 40x. 704 divided by 4, that would be 176, I believe. Yeah, 176 equals 0. Okay, so now we have to factor the trinomial. So 4x squared, oh wait, no. So we need to find, I'll cancel this out. we need to find factors of 176 that when we cross multiply them and when we add them both together, add the products together, it will result into positive 40, and when we multiply them, it will result into negative 176. So let's say 4 and 44, right? 4 and 44, when you multiply them, you'd get 176. So let's try that. 44 and 4. So since this is 44 and this is 4, when we subtract them, we know we're gonna get 40, right? So let's try that. When we subtract them, we get 40. When we multiply them, do we get negative 176? And the answer is yes. So we can use that and replace 1 by x, add 44, and then replace 1 with x, then affix negative 4 equals 0. So we know that the value of x is negative 44 and 4, right? Since negative 44 plus 44, that would be 0. 4 minus 4, that would be 0. So that's our x value. So yeah, the question is, what is the width of the sidewalk? We know that we can't have a negative x value. So our answer would be 4, since that is positive and we can't have negative 44 feet, right? That wouldn't make sense. So the answer is 4